Hey everyone, welcome back to J of All Trades. We're in the basement here again, moving along with this reno and finishing off the electrical that we're going to need in these outside frost walls. Now we decided to leave this basement unfinished for the first winter season, the first cold winter. Wanted to make sure we didn't have any moisture issues to deal with after that winter season, and it turns out we had a lot of snow, and we did end up finding some damp spots on the concrete. So these water marks ended up drying up in the spring when the temperature came back up, and we talked to the builder. The builder mentioned that this was part of the curing process for the concrete, and that we could have some dampness on the edges of the outside walls for a year or two, when we get into the cold season. Now, not ideal when you want to finish a basement, put some flooring down, drywall on the walls. You definitely don't want to have moisture, and so we spoke to them about it. We kind of gave them the benefit of the doubt on this one. So let me clarify a bit here. The electrical is being done to meet our local building code, and because the builder supplied outlets, they're just not ideal for a finished basement space. They give you 1, 2 if you're lucky. They're not anywhere near a space where they're needed, so it's just something that has to be done in part of the process, and the code sort of dictates what you need to do. So ours states that when we have 3 feet or more of a framed wall that's going to be finished in drywall in a basement, we have to have an outlet. These outlets have to have a certain spacing and be a certain height off the floor. So there's recommendations to follow, and you want to do this properly, and also give yourself the outlets in the areas of the rooms where you need them. So what are we up against here? In order to do this properly, we have to lift up the vapor barrier. You can see behind me here. You have to remove the fiberglass insulation, the bats, rather than slicing the poly, taping everything back up, trying to get the seal. It's better to lift it up and do the install properly. So, well, let me show you what we found when doing this. It ties into the moisture issue that we had, and I'm going to share a couple tips with you along the way. So here you can see we got the vapor barrier pulled up. I stapled it to the floor joist just to keep it up out of the way. We're doing a fairly long section to get our wiring in here. We have 12-foot spacing in between each outlet box is our code we're following, 18 inches off the floor. But let me show you what I found here, which is really interesting. First of all, let me point out what we call a double bottom plate, or a floating wall. So you can see that in this case, these walls are framed to float, and they will, if there's any deflection or any movement in the slab, this gap here on the double bottom plate will take up and absorb that deflection and not push up on your floor joist. So I mean, that was good to see. But one thing I'll point out right away here is that we're dealing with the minimum code in our case. This bottom plate here on this wall should be pressure treated lumber. That's what I like to see, and instead they've gone with a sill gasket underneath, which is just a thin white foam, and just regular lumber, again with pink fiberglass bat insulation sealing up the cavity behind this framing. Not ideal. I'd rather see pressure treated in here, but this is the sort of thing that passes inspection. So when we talked to the builder about this, they mentioned that they leave this bottom plate unsealed with acoustical sealant so that we can easily pull up the vapor barrier and run our electrical and put the wall back together, put it back down and seal it. So I thought, great, this is good. Less messy, easier to deal with. The acoustical sealant, I'll show you a sample of it here. It can be quite messy. There's an example of it. And yeah, it's gummy and sticky, and it gets all over everything. So I was kind of glad, but there's a reason why this is put in. I talked about poly in a previous video, but let me show you the next thing that I found where I really started to question what was done and why we were having moisture issues. So typically when you frame a frost wall in a concrete basement, you want to have an air gap between your outside concrete and your insulation. So take a look at this. We opened up the pocket, started pulling out the bats. First thing we see is moisture on the upper half of the concrete. Makes sense. You got a heated basement on the inside, you've got cold negative temperatures on the outside. Concrete absorbs the cold, and we have unsealed bottom plate where there's vapor barrier, there's plastic, but the heat from the inside of the basement, from the room, easily gets through this small bit of batt insulation. Of course, hot air rises, so it rises up the wall till it meets a point where you're dealing with the outside temperature in the concrete, not the below grade temperature down here. Look what happens. We got moisture. It's damp. So when you have this, this is typical. This would happen in any basement where you're framing and insulating. And when this happens, what you're supposed to do is leave an air gap. So the first thing I saw that I really didn't like was, take a look. The insulation is right up against the concrete. So what happens here? The insulation wicks moisture. It literally pulls the moisture out of the concrete into itself. And then what was happening, why we were seeing condensation and dampness along the bottom plate, was the insulation would fill up with moisture. And look at how tight that is against the concrete. It would fill up with moisture on this top half until it could hold no more, and then it would start to run down the walls. And when I take a look at the concrete, you can see evidence of the water running here. So done to meet building code? Sure. The code in our area is the R value of the insulation needs to be 15.6, let's say R16. So what did the builder put in? R22, and they said, hey, we've exceeded the code. Second thing I'll point out here that I wasn't too excited about, this batt insulation is very flexible. It tends to expand. It's not rigid like a mineral wool or a rock salt product. Certainly not as good as spray foam, but look at what they've done. They framed with a 2x4. They've used an R22 2x6 batt of insulation. What we're dealing with here is 6-inch material when it comes out of the bag. This measures 7 inches to the face of the 2x4, even a little bit better, 7.25 away from the concrete. So theoretically, you should have a 1-inch gap. And then if your concrete is, of course, it's going to absorb some moisture from the outside cold air hitting it, but that air gap should allow things to dry up, and you shouldn't get anything holding moisture there. Furthermore, if you have a properly sealed upper and lower plate, you're going to have your thermal break. That's what the vapor barrier is for. It's meant to stop the heat from the inside getting to the outside, stop the cold from the outside getting to the inside. So we didn't have a seal, obviously no thermal break on the bottom part of the wall, and look what happened. The heat escaped. Where it met the cold air, we have condensation, you could have ice, and then we have insulation improperly installed, wicking up the moisture. So had they framed with a 2x6 material, little extra cost, sure, in the building process. That's what I would have done, because number one, it's going to hold these fiberglass batts a lot tighter, and it'll hold more of the batt, and it'll stop this back portion from expanding, because you're putting vapor barrier plastic onto this batt insulation, and you're stapling it to the studs. So you're pulling it tight, and you're basically pushing on that fiberglass. So there's a gap back there. Where's it going to expand to? It's going to expand back to the concrete. This is what we found, and I'll show you what we're going to do to solve this problem, and hopefully it helps some of you guys if you're coming across the same thing. So let me show you what we're dealing with here when we pull insulation batts out and the concrete is wet. I've got some gloves on here, better to be safe. The stuff can irritate your skin. I've got a mask on. So I'm pulling out the batt. Look at what's left behind. The back of the insulation is damp. The concrete is wet. Some of the materials left behind, certainly not ideal. I don't see any air gap the way they're supposed to be. Older builds, when they go ahead and they'd finish a basement, especially in colder climates, some of the guys would put clear poly against the concrete just to give you separation between the insulation and the concrete, and it would prevent the insulation from wicking the moisture. So that was certainly one option, but what ended up happening is they ended up running into some mold issues. The plastic wouldn't dry out as quick. If you didn't have any air movement back there, it would hold moisture, hold it against the bottom of the wall, and you end up with some mold issues. Fortunately, we don't have any mold growing here. This is still fairly new, but we definitely want to address this, let it dry out, and I'll show you what we're going to do to remedy this situation and hopefully not have to deal with any moisture on the bottom plate in the future. So there's a couple options here, 2 or 3 actually. The best option, of course, for a full thermal break and to not have to deal with the vapor barrier and the sealing tape and the acoustical sealant is spray foam. Great product, full thermal break, easy to spray into these cavities, and basically you're sealing off any outside air from coming in, any inside air from going out. So that's ideal. But you know, one of the cons is it's very expensive. And we're dealing here with a basement that, you know, we have a gym set up in, it's partially, you know, being used. I'd have to basically throw away all the material that we've already paid for. So we decided to opt out of that. Cost prohibitive, and I don't want to waste material that you know has supposed to have come with the build. Second option, you can fasten like a building wrap onto the concrete behind your insulation. Some Tapcon screws, concrete nails. Basically, I would fasten a strip of wood across the top and then staple the Tyvek or the house wrap to that strip and run it all the way along the span of the wall. That's an option. It's gonna allow air to move through it. It's gonna prevent the bad insulation from wicking moisture if it's touching the concrete. I should mention we're not gonna go ahead and move this framing out any further. You know, 7¼ inches should be enough. It's unfortunate that this type of batt insulation expanded back against the concrete. So here's the option that we're going with. I ended up going with a rigid foam and installing it to the concrete with a little bit of construction adhesive, a little bit of PL Premium, and these mechanical fasteners. And I'll show you an up-close version of what this is, and I'll sort of go through the install quick with you guys here. As I move along, I'll show you an example. What this is effectively doing is it's creating the barrier between our insulation and the concrete. The insulation is no longer touching the concrete, not wicking any moisture. This also provides an insulating R value of, I think it's 3.75, so a little bit of additional R value, but we're also taping the joints, and effectively this rigid foam becomes our thermal break. We are spray foaming at the top, spray foaming at the bottom, and this becomes effectively our seal. So the vapor barrier itself isn't needed 100%, but it's in place. We already have it. We're going to put it back down, seal that again properly. And, you know, we don't have our air gap, but we should not have, you know, moisture transferring through this foam. This foam will not mold. And we're not going to, once we seal the bottom plate, all of our electrical's done here, we're not going to have that hot air escaping through that area and rising up and hitting the cold concrete and forming the condensation. So this is the way we've chosen. It still means I gotta tear the entire area apart. I was doing it anyways to get the outlets in the outside walls. You can see one there. We've got our proper vapor boot around the outlet. So an added step, but we've sort of discovered what I call a flaw in how they did these frost walls. We're going to remedy this, and we should have a dry, warm space, you know, to enjoy for years to come. So I'll go ahead and remove some of this, the remainder of this insulation, get my area dried out. You can see the moisture in the top half. We'll get this dried out, and I will go ahead and show you guys how we're installing this rigid foam with the mechanical fastener. And yeah. Well, hopefully this helps some of you guys if you have a similar issue, or you're not sure about whether you have, you know, the proper air gap, or that, you know, the insulation's done properly in your basement frost walls. So hopefully this helps a few of you out. You can see here, guys, as I'm taking out the top batts of insulation, these batts were actually put in when the spray foam in the joist cavities was still wet, and you can see some of the material at the very top edge that was stuck into the existing spray foam. Plus there was also a little bit of frost on the top edge of the wall, so I had to reach behind and make sure that I took as much of these batts out as I could, and still managed to have a little bit left behind. And then also, of course, pulled the edge pieces out from the bottom plates there. Okay, we got our insulation removed here for the section that we're doing right now. We've got cavities all cleaned out, all the debris gone. We've also made sure that any high spots on the concrete after the formwork was removed way back when, any high spots are taken off. Just a simple hammer and a concrete chisel takes care of that. But you want this insulation to be tight against the concrete wall. So yeah, now the next step is going to be to cut down our foam. Unfortunately, we can't get full sheets in here because of the height of this bottom plate. So as you can see here, we're putting in a good sized partial sheet, and then an upper portion goes in as well, and then we tape that joint. Spray foam the top to match the spray foam that's already in place in the joist pockets up here, and then we spray foam the bottom against the concrete before we re-insulate that. So the next step is to cut our foam. Really straightforward. Grab your Olfa knife, and what works really well is just one of these drywall T-square for a straight edge, and you can literally rip it standing upward. So we'll cut our piece, and we'll show you how we get this fastened on. Cutting these sheets of insulation is just like cutting drywall. You score the front face of it with your knife. You don't have to press too hard. Then you walk around to the back, you break the sheet just like drywall, and then you cut through the back membrane without ripping it. I should mention that these studs are 24 inches on center. So we found that with the rigid foam, there's enough room to grab your sheet once you have your cut made and simply slide it in between the studs, just to go ahead and check your rough fitment here before you put the adhesive on. So this looks good. Everything fits snug. We're against the concrete and against the floor. So yeah, it's handy that this frost wall framing is 24 inches on center. If it was tighter, you'd have a harder time getting these sheets in, and you might be better off to take these walls down and sheet the concrete, put the walls back up. But that's a ton of work. We're happy to be able to remedy this problem that should have been done right the first time this way. So as we normally do, let's go over some of the straightforward tools needed here to get this job done, to fasten these sheets onto the concrete. Aside from the sheet, the straight edge, and the utility knife itself, we are, for extra insurance, we're using some PL Premium Construction Adhesive. We're using, once the vapor barrier and the insulation goes back in, we are using a vapor barrier sealer, Acousti-Seal, just to seal up that bottom plate. We are using this style of fastener, about a 2.5 inch poly head on it, and this sort of a Christmas tree barb fitting. So this requires a 5/16 masonry bit, and this is a friction fit as you tap it in. The head's wide enough. I'll show you over here quick here. The head is wide enough to press on the sheet, and the barb end of this fastener grips the edges of the concrete, and they recommend that as you're drilling the hole through the insulation, I'll show you in a second, you leave some of the concrete dust behind, because that'll also help to hold this. These things hold quite well. I have no reservation of them coming back out, especially once the insulation, vapor barrier, and drywall is back together. So we've got our mechanical fasteners, basically board fasteners. This is a masonry bit. This particular one is an SDS bit. SDS refers to the type of shank that this bit has, going into a little bit of a larger hammer drill. A little bit of tape on here. What's the tape for? Well, I kind of want to gauge the depth. Take a look at our hammer drill here. This is a Hilti drill. These can be rented at many hardware stores, especially if you're only doing this job once and you're not a contractor needing to own the expensive tools. This is a Hilti hammer drill, lightweight, nice piece. It does have a depth gauge as well, but I just find it really simple to tape the bit. This way, as soon as I see that edge of that tape come in contact with the face of the insulation, I know I'm deep enough into the concrete. There's a breakdown of the tools you need to get this one done. Okay, so we fitted our sheet, we're happy with it. Now we're gonna go ahead and add some glue to the back, which is real straightforward. Just a couple of good sized dabs of adhesive. Usually just do the corners in the middle. So once we have our adhesive on the back, we're going to slide our sheet back through the framing. Keep this edge tight against the framing so you don't rub off any of the glue we just applied. And we're going to put our sheet into place. Okay, so in order to hold the sheet into place so we can drill all of our holes, I like to start with one in the corner and basically tack the sheet in so the bit pushes right through the styrofoam, and now we're just going to drill the concrete right up until our depth mark with the tape. And with this medium-sized hammer drill, makes quick work of drilling this concrete. Once we've got our hole in place, I'd like to use a rubber mallet to put these in because the mallet's about the size of the head and you want to drive them in straight. Make sure our sheet is where we want it. Put your fastener in as far as it'll go, and then you hit the head of it square on until it comes in contact with the sheet and it compresses a little bit. So that'll be enough to hold us in place. This seam is tight. We can drill the rest of our holes just like we did the first one. So I tend to put 5 of these on per sheet. The smaller portion on the upper part here, I'll probably get away with using 2 or 3. So as I mentioned before, we spray foam the bottom edge, we spray foam the top edge, and the seams are taped and sealed by this, what we call tuck tape or vapor barrier tape. This is the blue stuff. It's got a real strong adhesive on it. And this is as easy as just taping a seam. Your tape, start it out. Tape this all the way to the bottom and just make sure that the seam is good and sealed, and this is going to help create our thermal barrier, our thermal break between the concrete and the bat insulation. So tape is the end of this process. Then after that, you put your bats back in, vapor barrier goes back down that we're going to reuse and save. Okay, so just to recap, seams are all taped like I mentioned. All the insulation is PL'd and mechanically fastened to the concrete. We actually ended up getting our wiring run in, so our outlets are all tied together now. Now we're at the point where we're going to throw the insulation bats back in. So we'll get that done, and then we'll finally be able to seal up the bottom plate with the acoustical sealant and stop the transfer of heat to the outside wall.
Don't forget to put your PPE, your safety gear back on when handling this fiberglass insulation, and take your time. Make sure you're not compressing the bat as you're putting it back into the wall. Just tuck it in. Don't force it in there. Crush it. You'll see here I'm taking my utility knife and I'm making a small slit in the back of the bat so that it wraps around the wire. This doesn't affect your R value at all. It just helps the bat of insulation tuck nicely in between the studs and basically envelop the wire, create an envelope around there. So we'll continue this process until we got the whole wall filled back in with insulation, making sure to have our vapor barrier boot around the outlet.
Okay, you can see here we got our acoustic sealant on, a generous bead on the bottom plate. I like to just staple the poly down as far as I can get it reasonably tight. You can see how messy this stuff is. It ends up everywhere, so Take your time, do a nice job of it. I'm gonna lay this down now, press the poly into the sealant, put some staples into that bottom plate, and we'll call this one a wrap. All right, we call this one a wrap, but I do have to continue this process around the rest of the outside frost walls of this basement. Hopefully that helped some of you troubleshoot an issue you're having. If you have the same issue, just because the builder's done it doesn't mean it's done properly. So what I think we've got here is a good fix, a good compromise to save the existing material and get ourselves a basement that's going to be a little bit warmer, a little bit drier, properly sealed. So thanks again for watching, guys. Don't forget to hit the like button, subscribe for more content to come. See you on the next one.